guess this thing wanted to start my presentation already, so it's ready to go. So I'm ready to go. I'm going to be talking about hurricanes. And I'm going to talk a little bit about what we know. I'm also going to talk about what I would like to know, what we would like to know about hurricanes. This is Hurricane Isabel from the International Space Station. And the thing about hurricanes is they've influenced our history in a lot of ways, starting, well, in recorded history from how Japan resisted Kublai Khan's invasion in 1281 to why it's Houston, not Galveston, that we talk about in Texas as a major city. A slice through a hurricane reveals a really large circulation, hundreds of miles across, with a large cloud shield that you see from the satellite picture. Air spirals in at the bottom and up in the eye wall with the strongest winds in a narrow region where it's red. Complicated nomenclature. Typhoon, hurricane, and cyclone all refer to exactly the same thing, just in different parts of the world. The tropical cyclone is the most general term. Tropical storm is weaker than a hurricane, and tropical depression is a psychological state. No, actually, it's a very weak storm. The hurricane intensity scale, you've probably heard of the Saffir-Simpson scale. 1 is somewhat benign, but 5 could be catastrophic with 150 mile-an-hour winds plus. But about those surface winds, the strongest wind is actually very difficult to measure. It's not observed on land usually. We can't get an instrument there, and it can be very localized. So even though hurricanes are known for their winds and categorized by their winds, it's really the water that's what does the damage. And storm surge is what you hear a lot about, and it's this gradual, well, maybe not so gradual, but rising of the water ahead of the storm, like this image from Gulfport, Mississippi, ahead of Hurricane Katrina. And the water can get 20 feet deep or more. Hurricanes come in all sizes. Here's an example from September of 2010 where we have 3 storms at the same time, all near the same intensity, very different sizes. So size is not related to intensity in any direct way. Hurricane forecasts, despite what you might hear, are not that bad. A 3-day forecast typically has an error of about 100 miles. However, if you map that to the Texas coast, that's about 4 counties. And it really matters which of those counties the hurricane makes landfall in. So is it good or bad? It depends on your perspective. But seasonal forecasts are not that good. And this is an example of one type of human-generated seasonal forecast where some years it's okay, some years like this year it was pretty bad. It was supposed to be an active year, and we know in the Atlantic we haven't had any major hurricanes. So now on to the things we really don't understand, apart from seasonal forecasting, which we don't do very well. What governs the number of hurricanes that we have? Why is it around 85 tropical cyclones a year globally? It fluctuates, but it doesn't fluctuate that much. Why is that? How does climate affect the hurricanes? Here's an example where a measure of the hurricane intensity integrated over the season in the Atlantic matches the variations in sea surface temperature. That suggests that if climate influences sea surface temperature, climate influences hurricanes. Hurricanes affect global weather patterns. They push warm air northward as they move north, which creates an undulation that ultimately, sometimes, results in a snowstorm in Colorado early in the season. Will that happen this year? I have no idea. What causes rapid intensification of hurricanes? This is Hurricane Brett, which decided to intensify by 3 categories right before it slammed into the Texas coast. This doesn't happen that often, but we don't understand why it does when it does. What really happens near the ocean surface? This is my seasick slide, so beware. Where exactly is the ocean surface in this figure on the left with a Beaufort 12 scale wind and an oil tanker, and you can see the foam and everything. How do we best communicate hurricane forecasts? This was the unnecessary evacuation of Hurricane Rita. Way more people were killed in the evacuation than were actually killed in the storm. This is not a good practice. So how do we communicate these kind of risks? Now, what can be done to prevent these kind of disasters? Katrina in New Orleans, Mitch in Tegucigalpa, and Homestead, Florida after Andrew. Well, some have proposed mitigating hurricanes, but we really can't do that. The energy is far too great, and we really wouldn't want to because tropical cyclones bring vital rains, and the ultimate outcome of such intervention, I would argue, is probably unknown. Can we make better building decisions? You bet we can. The 3 images on the right are Dauphin Island, Alabama, before the major hurricanes of 2004, 2005, and you'll notice that the red circles indicate houses that have been built between hurricanes. It's probably not a good idea. One thing is certain, however, No matter what, hurricanes are going to continue to shape our civilization. Thank you.